double coefficient is
Yes.
-6.
Good. We divide it
Divided by 2,
and we get
3, or -3.
good. Now we have to square -3.
9.
Good. We're done. We're adding 9, and we're adding 9. Please remember, you must add 9 to both sides, otherwise you change the problem. And now we are just rearranging the whole thing, making it ready for taking the square root. 2 plus 9 is 11. I have to make it ready for taking the square root. As you notice, completing the square alone, as a method alone by itself, does not solve anything. It only rearranges the polynomial into a nicer form. But if I don't remember how to take the square root and how to do the rest of the steps, how to perform the rest of the steps, I'm stuck. I need to know now how to factor this. Otherwise, I can't continue. So, what do I have on the left-hand side?
X minus 3.
Very good. So now we take the square root. And I have x minus 3 equals plus or minus the square root of 11. Remember, the square root of 11 is not plus or minus. The plus or minus come from this side, from the absolute value. And x equals 3 plus or minus the square root of 11. And that's it. It's an easy method once you see it. Again, for solving quadratic equations, no. Unless you force me to. Let's look at a quadratic hypotenuse, the Pythagorean theorem. So let's look at this. Use the right triangle shown below, well, it's to the side, to find the missing length. Give an exact answer and a decimal approximation rounded to 2 decimal places. So they're showing us a right triangle. Obviously, this little box shows where the 90-degree angle is. And we have A, B, and C. And they're giving us A equals 3 and C equals 7. And they're asking us to determine the other leg. Okay, so what we need to remember is the Pythagorean theorem. And what does the Pythagorean theorem say? It says the following. I'm going to call this leg 1. Leg 1 squared plus, I'm going to call this leg 2. These are called legs. Leg 1 squared plus leg 2 squared equals the hypotenuse. The hypotenuse squared. Okay, the first leg is A, which is 3, and 3 squared is 9. The second leg is not given to us, so I'm going to write B squared. And then the hypotenuse is given to us, and it's 7, so I'm going to write 49. This is ready for taking square roots, but it needs one more step. Can anyone give us the extra step that we need to perform here? Before taking square roots, because I cannot take square root of a sum. I will never do that. So, what is the extra step we need to perform here before we take the square root?
Put it in a different order, like descending order.
You mean move 9 to the other side? 9 does not belong on the left-hand side.
No, it's talking about okay.
Now this is ready for taking square root. And this time I should write plus or minus. 40 is 4 and 10. Plus or minus 2, the square root of 10. And then I will say no, only because b is a length, so it has to be positive. This is correct algebraically, but incorrect when it comes to a side. It's a length, and the length cannot be negative. So algebraically it's correct. The answer is plus or minus 2 to the square root of 10, but because b is attached to a length, the negative solution cannot be accepted. Any questions on this problem, please? How do we feel about completing the square? This was not completing the square because it was straightforward, taking square roots. How do we feel about completing the square? Can we move on to the very last method and then come back to other problems? Okay, finally, method 4. Method 4 is quadratic formula. Quadratic formula can be applied in all situations when solving quadratic equations. In certain situations, I don't recommend it, but it can be applied. But it can be applied only if the equation is in standard form. A leading coefficient x squared plus the middle coefficient times x plus the free term equals 0. This is the standard form. If the equation is not rearranged in the standard form, we cannot use the quadratic formula. So this is the standard form. Let's suppose I arrange it in the standard form. What do I do next? Well, we have to remember this is very easy. Create a tune, attach the tune to it. Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac. Please remember that this piece will always be positive. Whatever b is, when you square it, please do not ever start with a negative number here. Whatever you have when you square it, this is positive. Okay, so let's look at an example. Let's say x squared minus 4x minus 7 equals 0. It's already in the standard form. It's in descending order. I know a is 1. I know b is negative 4. Remember, you have to take the number with a sign in front. And I know c equals negative 7. All I have to do is take these numbers and plug them in. So then x equals negative b, 4, plus or minus. B squared, it must be positive, minus 4 times a, I shouldn't even write it, times c, in parentheses, negative 7, over 2 times a. Again, negative b plus or minus the square root of b squared minus 4 from the formula. A is 1 times c, which is negative 7. That's why I was saying that one of the questions that you had at the beginning, if I find it quickly, maybe, maybe not. Here, yes, there was right under my nose. Okay, so 4 times 7 is 28. I have to multiply these two. So then x equals 4 plus or minus. So 28 plus 16, 44. The square root of 44 divided by 2. If you attempt to simplify a term with a factor, that would be a terrible mistake. Okay, we continue. X equals 4 plus or minus. I have to write it as the square root of 4 times the square root of 11 divided by 2. It has to be a product so I can simplify it and split the radical. If it's not a product, I can't for a quotient. Okay, good. So then I have x equals 4 plus or minus 2, the square root of 11 divided by 2. Now I have those two options from last time. I either split the fraction or factor out in the numerator. I prefer to factor, so I would write 2 plus or minus the square root of 11 over 2. And then I simplify. And the simplified form is 2 plus or minus the square root of 11. Any questions on the quadratic formula? Okay, let's practice. And then I have one more thing to say, and that's the end of the new material, the end of the course. Okay, so let's take a look. This is the last section. I didn't talk about the discriminant. That's the last thing that I need to do. So let's just solve the quadratic equation using the quadratic formula. And I'll come back to the discriminant. That's the last thing that I need to say. The last new thing that I need to say. So we have 3 equals 5x squared plus 8x. Good. What do we need to do first?
In standard form.
Yes. So I have 5x squared plus 8x. I move 3, it becomes negative, and set it equal to 0. It doesn't matter how you write it, from left to right or from right to left. The only term that has to be moved is positive 3. Good. Now I identify those coefficients. Here is A. Here is B with a sign in front. And here is C with a sign in front. And now I prepare the quadratic formula. What I recommend, always write it, negative b plus or minus, then you will remember easily. B squared minus 4ac divided by 2a. And now carefully plug them in. Negative b, negative 8, plus or minus. B squared, 64, minus 4, times a, which is 5. Times c, which is negative 3, but you need parentheses, over 2 times a, which is 10. So let's see this one more time. Negative b plus or minus the square root of b squared minus 4 from the formula, a, which is 5, times c, which is negative 3. Remember, you cannot write multiplication and the negative symbol setting one next to the other. And now I have to perform those calculations. So x equals negative 8 plus or minus. Let's see. Obviously, the square root, I have a 64 and I have plus. Always take care of the sign first. Get it out of the way. Because negative 4 times 5 times negative 3 will be positive. 4 times 5, 20. 20 times 3. Sorry about that. So 4 times 5 again, 20 times 3 is 60. Everything divided by 10. So then we have x equals negative 8 plus or minus 124 divided by 10. Do not attempt to simplify 8 with 10. This is a term and this is a factor. But I have to simplify 124. I have no idea what this is. So I take it aside. It's an even number, 62. Again, an even number, 31. And it's done. 31 is a prime number. So then I will rewrite it as x equals negative 8 plus or minus the square root of 4 times the square root of 31, everything divided by 10. So x equals negative 8 plus or minus 2 the square root of 31 divided by 10. I can simplify it, but I will factor out a 2 in the numerator and then simplify. 2. Negative 4 plus or minus the square root of 31 divided by 10. Now I will simplify because I'm simplifying factors. So the final simplified form is negative 4 plus or minus the square root of 31 divided by 5. We have one solution with plus and one solution with minus. And remember, Pearson will ask you to write them with a comma. The quadratic formula is pretty straightforward. However, simplifying radicals and then factoring and then simplifying till the fullest, it's more cumbersome. Plugging in the numbers in the quadratic formula, not so much. You just have to be careful. Now, if you remember the quadratic formula one more time, negative b plus or minus the square root of b squared minus 4ac divided by 2a. 2a. This quantity is very important. It tells us a lot about the quadratic function. Not the square root, just this quantity. b squared minus 4ac is called a discriminant. The discriminant. Knowing the discriminant, I can tell you what type of solutions we get. How come? B squared minus 4ac, you noticed, in this problem was 124. In this problem was 44, and so on and so forth. This is the discriminant for this problem, 44. For this problem is 124. So b squared minus 4ac is a number. It's a real number. So let's discuss the different cases. So b squared minus 4ac. First case, if it's a negative number, trouble. Why? Because the square of a negative number is not real. And I will say the equation has no real solutions. Second option. As an example, the square root of a perfect square. Like the square root of 36, for example. Then the solutions will be rational. in both situations that we had, the square root of 44, there is still a radical left. So this is not rational. In the next situation that we looked at, we still had the square root of 31, not rational. We did not hit an example like that. So how will that look like? Something like solutions equals 1 plus or minus the square root of 4 divided by 2. Because it's a perfect square, it's the square root of 4. I can take the square root of 4. So then I have 1 plus or minus 2 over 2. And then I have two possibilities. 1 plus 2 over 2, which is 3/2, and 1 minus 2 over 2, which is negative 1/2. So the first, we haven't done, we're not finished. If the radical is, or if the discriminant is negative, the radical of a negative is not real. So the solutions will not be real. And next option is, when we take the square root and it's a perfect square, then I get solutions will be rational, two rational solutions. The third option, when I take the square root of 0, in other words, the discriminant is 0. What is left? Then only x equals negative b over 2a is left, and nothing else. Two real, identical solutions. Because there is no plus or minus. I don't have a second one, but I know that it's quadratic. We have to get two solutions. It's a must. I have to get two solutions. You can say one real solution, or you can say two real identical solutions, same thing. And the last possibility, when we have the square root of 44, the square root of 3, and so on and so forth. Those will be rational solutions. I'm sorry, irrational solutions. These are all four options.